Welcome. In this video I'm going to show you how you can perform a Fisher exact test for 2x2 tables using Python. I'm running Python version 3.12 and I'm running this in JupyterLab, but this should also work in any other IDE. This video will focus on how to obtain the p-value, not so much if you should be using this test. It is important that this test assumes fixed margins. So if your experiment doesn't meet that assumption, then you probably need to be doing something else. To show you how this can be done, I need some example data. So I've already imported pandas. I loaded in a data frame, student statistics. I don't need all its data, so I only needed two fields. I'm going to be using the general secondary school question and the general gender question. Remove any missing values from there, and then for the gender was already binary because no one opted anything else besides male and female. Secondary school was a long list, but most were from the Netherlands because that's where this survey was held. And anything else I'm just going to replace with other. And then a quick cross table was made, so you can see that, for example, 15 male students who had their secondary school outside of the Netherlands. I have a separate video where I show you how this can be done with my own library, which simply has a function to produce this. But if you don't want to install my library, SciPy also can do this. It actually requires that cross table as input. So here is that cross table again. We then, if you've never used SciPy, you will need to install it first using pip install, and then you can use from SciPy stats import the Fisher exact. You can then just feed it that cross table, and it returns the test statistic, which is probably the p-value from the table, I think, and the p-value itself, which is 0.2988. That's above the usual threshold of 0.05. Oh, sorry, 0.4 was the odds ratio. The 0.2988 is above the usual threshold of 0.05. Which means we do not reject the null hypothesis and therefore claim that there is insufficient evidence that there is an association between gender and secondary school. If you don't want to use any libraries besides the ones from Python itself, we can say, well, in general, we have a cross table like this. We call this A, B, C, and D. So let me get those from my table. Still using a little bit of pandas there. The row and the column totals are now easy. A plus B, C plus D. Row totals and the column totals A plus C and B plus D. All right. Then the overall total is just the sum of the column totals or the sum of the row totals. And now for that probability. It's using this formula. You can choose either this one or that one. They're both the same, where this is a binomial coefficient, which is defined as the factorial of x over the factorial of y times x, the factorial of x minus y. Factorial just means to keep on multiplying. So, for example, the factorial of 5 is 5 times 4 times 3 times 2 times 1. The math library has a combinations formula that actually can do this for us, so that's immediately this one. And we can fill out the formula. This one, as you can see, is just filling out the formula, and that gives us our probability. Oh, I of course need to first import my math library that comes with Python, and then that's the probability of this particular table. So we need to find all probabilities just to check the other one gives the exact same result. All right, so before we're going to check all of them, I'm just going to make a small table that actually calculates this small function. So I can now just use that function to calculate that probability, because we need to do this for every possible combination. And basically what we're going to do is we're going to range starting from the maximum of these two, either 0 or this one, up till the minimum of the first column and the first row, plus 1 because it's inclusive. That's the range that actually this value, let me go all the way back up, this A value can actually be. If it's any higher, then it's going to be above my column total or above my row total. So that's not good. And if it's any lower, it's going to be giving a negative result for either of the other ones. So that's no good. All right. So all the way back to here. So now I'm just going to actually run over that and calculate every time for each possible value of A, the probability of then that table, because all the other values in that table can then be found. If you know one, you know, and you know all the totals, then you can simply calculate all the other ones. We only need the ones that are actually less or equal to our sample one. So instead of doing all of them, I can actually just already add that to my so-called p-value, and that gives us the exact same result as we saw earlier with SciPy. All right, I hope this video was helpful, and thank you for watching.